This is a very specialized topic for people I have coined as Pythonistas, people who use Python. For those of you who have not seen the blog that has a little interview with Paul Nelson, please do. It summarizes a little bit about the new Python integration, but also will give you a little bit of a peek into the personality of that jump developer we know as Paul Nelson, and some interesting things about what he does when he's not down the hall from me. Everything you're seeing today will be in Jump 18 and Jump Pro 18, of course.
We've made lots of changes between Jump 17 and Jump 18. Jump 14 through 17 were pretty much remained the same. All of you that have struggled through getting the Python integration to work in your systems know that that was the biggest challenge, was just getting Python integration to work. The variety of environments that Python installations on your machines, the scripts couldn't even depend on the same consistent version of Python. So what we've done in Jump 18 is to install a version with Jump on the installation of Python 3.11 as a embedded, isolated Python. Think of it as your own private virtual environment for Jump. This allows us to provide a tested and verified version, so we know it works. We've tested it, so when you get it, it'll work out of the box. Next, those of you that have programmed with the Python from JSL know how challenging it is to take a language that depends on spacing for your block structure, to put it in, paste it in as a string within a JSL statement. And the error reporting was not up to what's needed for development. Jump sucked up most of the error messages and you only got that the script succeeded or failed. So we've greatly improved the error reporting, but we've also given you a Python-aware script editor. You can now, within Jump, a script editor that you can run pure Python scripts from within Jump, as well as support for the log and the embedded log, and you will get the Python backtrace when things go wrong in Python. We've added capability of accessing Python, accessing Jump's functionality from Python. You can now create data tables. You can access the data table live from Python, and all of the functionality that we've added with the API from Python to Jump, we've now created a separate Python category in the scripting index that lays out examples and documents all of the capabilities that we've now provided from Python. There's lots of things that Jump's good at, but there are so many Python packages out there that can make Jump even more powerful. So what we wanted to be able to do is make it easy for you to extend Jump by pulling in external Python packages, such as data formats we don't support, or statistics we don't yet support, or even things like utilizing the GPUs. And finally, see this as a peer to JSL, not a replacement. The Python, we're trying to make sure it's a comfortable, familiar environment for Python programmers. So for example, it's zero-based indexing where JSL is one-based indexing. We didn't want to change that. We want to make sure that it behaved the way a Python programmer would expect our objects to behave. So let's show it already, the fun stuff. So we have all the old ones. We still support them. because we are supplying a Python, things like Python Connect no longer accept arguments. Python init doesn't take any arguments anymore. The arguments to them are deprecated, and because Python Connect does everything that init did, we've actually deprecated the Python init as well. The benefit, the Python Connect, one thing it does is gives you the object so that you can send messages. One I will point out, the Python get graphics has been completely removed. But in the scripting index gives basically the workaround on how you can do exactly what JMP was doing internally. This means we no longer carry a dependency on matplotlib. You can use matplotlib and pull it in, but JMP is no longer dependent on it. The one I want to show, two things, is to make installing packages easier. We've added a Python install package. You can just, from JSL, this is all you need to do is you can install packages from here, makes it easy, and it puts them into JMP's private isolated environment. We've tried hard to make sure that this won't conflict with any other Python pipeline that you may have on your system. But that means you'll have to install packages into the JMP environment. The other is if some of them that need compiling from the command line, you may need to do that from a terminal window, and create JPIP command will launch a file, a dialog, a directory picker dialog for you to save a JPIP wrapper script. So that's our script that wrappers Python's pip, but specifies the appropriate environment variables so that when those packages are installed, they wind up in a place that JMP can find them, your user's application directory. But over here, we have an entire Python category. This is where we've created an import JMP package that gives us the capabilities for you to call JMP from within Python. Lots of things laid out. Most of you'll find sample directory, project directory. These things are all sample data. If we run the script editor's aware. It will give you the same sorts of things that you would get from the JMP's $ special directories in JSL. We also have the ability to run JSL from Python. This is our first release with supporting functionality from Python into JMP, and there's a huge amount that JSL can do that we've not been able to have time to implement here. Our focus has been on the data table, being able to interoperate in memory with a data table from Python, be able to send our JMP data table from Python, from JSL to Python, be able to operate it live, and vice versa. So with the run JSL, some of the things like formatting columns, column width, setting formatting types, that's not available in Python at this point, but you can do the run JSL to do those things from your Python script. So this one's a good example because it shows us creating a data table from Python, and we have a data table object, optional parameter of the number of rows, and we can run the script in pieces just like you can with JSL. So that created a column, 5 rows, created a column with 5 rows. And let's see if I can make enough space for things so they don't. clash. And as you see the embedded log, we get the output down below. We've got properties on it. We can set the table name. We can add columns to it, and we've got an enumeration type, so you can character type, default is numeric. You can specify that as well. And as you can see, when I run this, it's live. You're operating on the data table. We can access the array access operators. It's column row, jumps column based, so we access it by column and row. And the column can be accessed either by name or by zero-based index. So the name column, we can set the name column. Boom, created the names, filled them in. I want to show here, this sample, this is a bad value. It's a numeric column, but I wrongly put a string in there. Well, we get a missing value, as we would hope, as we'd expect. And we'll set that value with the individual cell and row accessor. And then, now the point of this one was to run JSL to show how we can set the formatting by having Python call JSL, and there we go. So there's lots here in the scripting index. One of the other things, so I wanted to show, and I'll talk about, and one of the questions that came up was, in the past, 14 through 17, when you sent a data table with the Python send from JSL, it created a pandas data frame. But the way it created a pandas data frame was it told JMP saved the data table out as a CSV file. And then it told pandas to read that CSV file from the disk. That blows up if you've got large binary files. They become huge text files. And you also have concerns over loss of precision because you're going from binary to text and parsed back to binary. So that is one change that you'll have to make in your existing scripts, is that when we do a Python send of a JMP data table, you wind up getting one of these JMP data table objects now instead of a pandas data frame. What you get for that, though, is it is live access to the table. It's not a copy, and it's done all in memory. It's actually just a pointer to the data table. I'll show in one of the samples here, it's very easy to convert from our JMP data table object to a pandas data frame. And conversely, it's easy to build a JMP data table object from a pandas data frame, basically column at a time. This also allows you so the next sample I'll pull up is a Parquet file. Apache Spark uses a Parquet data file format. And that's one of them that's been frequently asked, of how can JMP support Parquet files? Well, using Python, we can easily pull up Parquet files. And that's popped up on my other screen. And so there's a GitHub Apache license sample data. That's where I've pulled this file from. It's got names, and it's a sample data with names and salary and things like that. So we will import the PyArrow package and the types package so that we can look at the schema of the table to generate know what kind of column types we need to build in JMP. And this only works at this point in EA6 or newer. So you'll notice I put a version on our jump package so that you can tell, and we will update that with, jump version is now 1.0.0 for jump 18. That's the version of the jump import package. So, and then here, basically I built a simple function that takes a data table, a parquet table, and a column name, and we go through it, check the schema for the type, build a jump data table column based on that schema type, and assign the value. And down here, I'll run it in a minute, but so this is all it takes to create the data table from the parquet file. Is we create the data table with the number of rows, and I'm only going to take 4 columns out of this table, even though I could just as easily take them all. And that's all it takes. Run a loop on my function to build the columns. And then again, as we've seen, to run the JSL to set the display widths and the column formatting. And then down below is just some print statements to output the schema of that table. So we'll run the script, and it popped up on my other screen. But here we go. We have, from that 1,000-line parquet file, we built a date time column, names, and salaries, including a few missing values in here. Nicely formatted. And then, so this goes to our ability to help you expand Jump's capabilities. Jump supports a lot of file formats, but we can't support them all, but there's all kinds of Python capabilities to support esoteric file formats and what might be specific for your needs. Modern desktops and computers often have powerful GPUs, and without utilizing those GPUs, we leave a lot of power on the table. So here's an interesting one. I get it? Where'd it come up? All right, where's the window? There we go. Can't click, apparently, to save me. Open Compute Language, OpenCL, is one of the ways to utilize GPUs. There's a Python package, PyOpenCL, that lets you create GPU kernels and run them from Python. We pull those in. This sample demo I found creates a 2K by 2K Mandelbrot fractal. That's a lot. It's actually a lot of computation, and the sample had code for doing it serially on the CPU using NumPy or using OpenCL. On this MacBook Pro, it takes over 16 seconds if I run this on the CPU. And I'll just show you, let's see, let's pull up I'll let it run to the regular log so I can show you that output goes to the log, or if we do the embedded log, the output comes here. I'll just let it go to the regular log for this one, and we'll run the script. That's how long it took to build a 2K by 2K fractal using the GPU on my Mac. And let's look at the log. Okay, that took 0.08 of a second. rather than 16 seconds to run it on the CPU. This provides lots of ability if you need or want to run code on your GPUs. You can do that from here as well. PyCUDA, I've tried on my Windows machine, and you can call that from Jump there as well if you install it. The other one I showed at the keynote was some statistics. You may want to add statistical capabilities to Jump that we don't do yet. And what we showed was you might want to do density-based clustering and HDB scan, hierarchical density-based clustering, is something that Jump doesn't support at this point yet. Where's the window? Did it come up? It did not come up. I can't click today, or my mouse is not. All right. There we go. Got it. So in this case, so I'm taking, again, I'm showing the use of our Jump package and the open command. I'm just pulling a file from our sample data directory, the life sciences genomics table. Here, we create this is a Jump data table. This is how simple it is to go from a data table to a data frame. I'm taking it column at a time. I'm using the slice command on the data table to take columns 10 through 70. And we just assign the data frame's column name to the list of the column. And so going from our data table object to a pandas data frame is fairly trivial, and coming back from a data frame to a Jump data table is similarly easy. Do the cluster, plot, and use matplotlib to draw the figure as an image, and then we'll open the image file. There is an issue with matplotlib, especially on the Mac. If you try and do it interactively, they conflict with Jump's main window loop, and you may get a crash. So if you force matplotlib to use the non-interactive backend, everything will plot just fine, and you can save it as you draw and save it as a figure, as an image, and we can get the output. So let's show the embedded log, and we'll run script. I must have had something highlighted, so let's run script. And it's taking a little bit of time. So there we go. We have the data table. We have the hierarchical cluster output. And in our embedded log, we get the results, the Python results from the clustering, HDB scans clustering output. So one of the other things I can show, let's see, I haven't tried this, so bear with me if I screw something up, but we're talking about, we improved the output much better, the error reporting output. So let me just delete something here and see how that runs. So now you actually get a meaningful output back from Python that tells you right where the error happened. It's line 1 because I only ran one line of code. But if if I'd let the whole thing run, and I can try that, I can show you that again. We can just run the whole thing and it'll give you the line where it died. Some of this other, the table worked, but so line 40, yep, line 40 is where it happens. So that's a good portion of what we've shown. If there are any questions, Gail, we can start addressing some things.
Yeah, the questions are pretty much about the installation and the environment. Are you going to cover that at the end, or do you want to answer them now?
Sure, I can talk about that now.
Okay, and there's one that I did answer. The person was wondering whether the Python packages are in the same folder as the JMP installation, which they would need admin rights to write in, or in the Windows user folder. I think on mine they're in the Windows user folder. Can you clarify?
I can. The on Windows, some of the Python installation itself winds up with JMP in JMP's application directory. However, when the place we install packages is in a user writable location, that is the app data directory, on Windows app data, where JMP stores the rest of its stuff, preferences and all of that in the app data directory. On Mac, it's the user's library application support JMP folders. So the installed packages are all set to go into a user writable location, including the pip and setup tools, so that you're able to update even the setup tools in pip when new versions occur. JMP itself installs on Windows, the Python executable winds up inside JMP's application folder, and on the Mac, it's within the application bundle as a Python framework. And that's laid down when JMP is installed. When JMP runs, it creates, the first time you run the Python, it will unpack the minimal site packages that we have and lay out and we supply a Python 311.zip that is the Python standard libraries. We're not shipping any third-party packages with it. It's basically a Python 311. Currently in 18 is 311.5. Our next update will contain 311.7 or 311.8. There'll be the security update. And we will stay with Python 311 throughout JMP 18's lifecycle, making updates as bug fixes and security patches occur.
This does not require Anaconda, Miniconda, or Conda. Does it, Paul? The person is concerned because there's a cost to license those platforms.
No, this does not use any of the Anaconda distributions. This is a python.org Python distribution that we have embedded with JMP as part of JMP.
Thanks. And just to confirm, JMP supports all of this from Python directly, and PY, is it PyPy, PyPy or PyPL packages?
Yes. I'm trying to think of, well, so let me show you within our JMP utils. We can also create the command line pip file, but we also have the ability to, this is a little more opened up version. The JSL one, you just give it a space delimited list of packages. But here, this is more of a direct analog to pip. And for example, install NumPy and Pandas. And I'm trying to think of one that, let's see what I have in my list. This one, we can run the list, JPIP list, and this will tell me the packages I have installed on mine. Let's see.
And I'm not sure, is this called PyPy or
Yeah,
PyPL?
so Pi, the normal package distribution where stuff usually gets pulled from. Yes, that's where this will go look. I'm trying to think. Okay, so I don't think in this one I've installed the crypt. There's an encryption crypt dome. So let's just do an install. Run jump utils. And then let's do jump utils dot pip. So it's running a sub process. that I went out and downloaded the PyCryptoDome package, and successfully install it. You get the output of pip back in your window. That's what? Yeah. Yeah, that's one of those. Most of the packages, it's the same name as the as the package name, but in this case, this isn't one. But that allowed us to pull in a cryptography package. I think that's the right. Yep. So, any other questions?
Yes, we do. Andrew, you can unmute. Did that answer your question?
Yes, it did. Thank you so much.
Thanks, Andrew. If Python 3.11 is the default version, what about using libraries that rely on older versions of Python? Will there be some level of backwards compatibility with no guarantee of the script running?
So going to completely depend on, what you can get from the package repositories. If there's a version for Python 3.11, because all those repositories tend to version them. I mean, if they work across versions, then you should be fine. But if there's version specific things, then it may not run. Or you may not, it'll typically say, package not found, can't find the package in the repository. The only other issue we've run into a little bit is some of the packages out there do require compilation because there's no pre-made binary wheel. If you run into one of those, you need to have a development environment on your system so that it can compile those packages. And in only a few cases, it's been necessary to not only have the development environment, but install a standard Python 3.11.org Python distribution and use pip to install and compile the Python package locally on your machine for the standard Python distribution. And then with jumps JPIP, it will find that compiled, locally cached and compiled one to install it into jumps environment. So you shouldn't run into that except for a very few number of packages, but that's the workaround if you have to, if the JPIP install fails and can't complete the compile, because there's some that don't behave well. But they tend to work fine if you do install it for a regular Python, and then jump can find the pre-built one.
Thanks, Paul. Alex had a question. Is it possible to have different environments for Python in JMP or to clear the environment and start over?
Different ones, not, well, yes and no. If you go into your app data directory and find the Python folder, rename it and set it aside, and JMP will recreate the environment the next time up, and you'll have to put all the new packages in. Similarly, if you just blow that away, you've got something weird going on, you can blow that directory away, and when you run JMP the next time, it'll reestablish what we need in there, and you can start putting packages in there again. That is something I'm looking at moving forward, is to be able to have multiple virtual JMP environments, but that's not something that's present in 18.
Thanks. Norman has a question. Can the package installation be redirected to a controlled, I think he means repository? They can't install directly from pypy.org without auditing them first. It wasn't clear, he said, if you could, for example, create a venv, do package installation, and then run that script in JMP script editor.
No, we don't support the venv. Our own environment is very close to a Python virtual environment, venv, and I'm trying to make them so that they are, and that would then help us to be able to do multiple ones with JMP. One of the things that most of those redirected packages, one of our EA customers, their packages come from a G Cloud environment. And that was challenging, but we did get it to work for that user. And it means carefully tailoring and changing some of the adding variables to that the JPIP wrapper, because most of that's controlled, and that, again, our JPIP script, our wrapper script, is just a thin wrapper over the top of pip itself. So if you wind up having, environment variables that then direct pip to go to your cloud storage package repository, or then the same environment variables should be and can be put in that script that should allow you to work. That's something that we, try and improve upon as we go forward, as to how to help support that. But right now, certainly tech support, and probably they'll wind up talking to me directly, but or us talking directly to help try and set that up. But because it's not as straightforward, but it's not too bad.
So, Paul, that person can route a request through tech support to you?
Yep.
Thank you. Is it possible to read the JMP Python environment and know how many packages you have installed? This person says a user would like to keep track of the packages version.
Well, that one the pip will give you the list of the packages installed, and that's what I've got installed in my JMP environment at this point.
You showed us that when you were looking for them. Thank you. Is there any tab level dependency to the Python code in the environment? Do you need clarification on tab level dependency, or do you understand it? Can you clarify, please?
Yeah, so JMP JSL editors, they don't care about spaces, carriage returns and things like that, or alignment of open and close of different functions and stuff, but Python environments do. Is there a dependency for that in this Python environment as well?
Yes, though I believe we can try it out. that the editor doesn't let you mix tabs and spaces, but we can try it. So okay.
So you're saying it follows Python conventions,
It does.
Paul?
The Python, this is in the Python editor, you've got and I believe if we forced a tab in a space, you might still have a trouble, and that's something I certainly want to look at deeper. I'm trying to find one of the examples that has some code. And let's pull back one of the others. Is this one having? Come on, mouse. There's basic jump. Look at that. Is this having indentation? Parquet one did. So
you're forcing a tab?
yeah, I just want to see what happens. So here there is a tab. So let's get 1, 2, 3, 4. Right. Yeah, let's use the embedded log so we can see it. Yep. So you still can get, just like Python, if you mismatch this one's a tab and this one's 4 spaces. So you can get that mismatch. One of the things that, again, I'm looking for is likely this grayed out reformat script button that's familiar from the JSL side of thing. That's probably the functionality that will assign there, just to walk through it and make sure it's all consistent tabs or spaces.
Okay, that was kind of a follow-up concern. Would the reformat potentially misalign those levels?
At present, the reformat is not enabled.
Okay, thank you.
So are we talking futures, Paul?
That is one of the things that to look at the future to make it much better, easier, more inviting here in the Python editor. There was so much infrastructure to put in place. Some of the things like that didn't get addressed yet. While we have the code coloring, this doesn't automatically indent either. It should have, that's something we're looking at as well.
Question about the interaction between Python and Jump Live, and I needed Nathan to clarify. He said, for example, if I wanted to do a Python statistical analysis currently not in Jump, can
Right.
he publish that analysis report to Jump Live for his organization to view and interact with?
If you can get your output into Jump in a Jump report, probably then you can publish it. Just like I showed with, is this the one with the HDB scan, the image, I saved the image out and brought it back in as a Jump window. If you can get it into the format that Jump is expecting to be able to publish, then you could publish that report. We've done a lot of integration work. There's certainly more to come. This is a foundational change of what we're trying to do with JMP and make it more accessible. And things like that are certainly to be looked at in the future. At present, JMP Live does not support Python scripts running on the server. We are looking at that, but there are security concerns about file access and internet access and other things like that. So we've got to do a deep dive in making sure that if we enable Python up on JMP Live server, that we're not compromising security.
This means really basically I'm going to default to the JMP 3.11 version of Python, and that's just sort of a trade-off I have to make, correct?
If you're going to work within JMP with Python, yes, you're using Python 3.11. This doesn't limit you from having another version of Python on your system, but it does mean you have to wind up figuring a way to interact with the two, like saving a file out. I mean, you can use the Python within JMP, say to create a pandas data frame or a Parquet file, and then save that file out someplace where your external Python process takes that Parquet file and goes on and does something else with it. The focus here with what we've done with the Python and JMP is to provide an environment that just works. And the other reason why Python 3.11 was chosen was Python.org supports a version only for 5 years for security and bug fix updates. So we picked a new enough version to have enough of a lead time for us to develop this, as well as to support it through at least a full JMP release before there's no more bug fix and security updates. Once that becomes an issue of it becoming end of life, JMP will switch to a newer version, but we will try and make sure that switch is like at 19.0 or 20.0 so that the Python release is consistent from 19 through its life cycle. We've also tried to make sure things like MATLAB, when I started this, they did not support 3.11. They supported 3.8 through 3.10, but last fall 3.11 was supported. That was my hope, and I gambled correctly. We will try not to break, if we move forward. We hope the other packages that you may depend on will have moved forward, but like I said, we'll try and keep 3.11 until we have to move forward due to bug fix and security concerns.
If you want to access a JMP data table from a Jupyter notebook in a different Python environment, would the import JMP instructions still work?
Sadly, no. The import JMP package is only available within JMP because it's not implemented in anything but C++ that's internal to JMP. That bridge between Python and JMP exists only within JMP's source code.
One final question, I believe. Today, as a user, the person can create add-ins in JSL. With JMP 18, can they create add-ins that combine JSL and Python?
Yes, with the caveat that the add-in builder does not recognize Python files yet. However, you can, if you edit the zip file yourself, that the add-in winds up in, you can place the Python file into the add-in and the JSL can run, say Python submit file, and it will find that file local to it in the same place that the other is. That to make that better and potentially make it so that you can make a Python add-in is definitely being looked at.
Certainly, if you're going to create an add-in and put it out in the JMP community, do put some text in there that says that it is a Python JSL add-in. That's a new, it'll be coming in as a zip file anyway, so we'll be able to save it into the community, but I would be delighted to see some text that describes that for our users. Okay, that was the end of a very long series of questions. I think you have more to cover, correct, Paul?
I have a couple other examples to show that I can go through. One of the things that the samples I didn't show at the keynote was, so we can connect to R through Python as well. My preferred way is, since it's a lighter footprint and lets you run R on any machine. If you use rserve, you can put the rserve can be running on can be running locally on your machine, or it can be running on a Linux machine somewhere off in the cloud or on a beefy server. So this sample, I've got rserve running on my Mac here locally. And in this sample, there's, the directions on how to install and set things up. But I've played with this with running it from my Mac to a remote Linux machine. I've run rserve on this local machine. I've run it on my Windows box locally, and I've run it on my Windows box where rserve was running within Windows subsystem for Linux. So the key thing, is you import PyRserve and NumPy, and our import jump. And then, so this one just does really simple. I mean, is you make a connection, you can creates a R vector, sums it up, prints the result, and I'm printing the version that my R is. The connect will actually print the version of the PyRserve version, or that's here. I'm printing that. So if we run the script, we connected to PyRserve. The R is that version. Here's the vector and result. So again, the flexibility that the Python affords is great. To show one of the things that, let's see, does this one have the slicing in it? This one does not. You can do lots of fun things. I've got a sample. Well, we can run this one, and then we can just do it by hand. Script. So we got a data table. But let's do, like I said, it's column row. But let's take and print, if I can type, ET 0. Let's go 1, 2, from the beginning, 0, 2. We got 40 columns. Let's go 20. 20 by 2. So we support the slice syntax. That'll give us every other name. Out of the data table, starting with the 0th element. So we've tried to make sure that everything behaves the way you would expect as a Python programmer. We've got you can get the number of columns either by the length of the data table. That's in terms of columns. Or just like in JSL, there's an nCols property. Same thing if we take the length of the column object, we get 40 rows. And again, there's an nRows property on the column. And this one was so you could obviously see things happening live, that it truly is the access to the table. And changed Katie to lowercase. The other thing is we've tried to make sure that we've generated the Python doc strings. So you can run Python's help, and this gives you all of the outputs of what the jump object help from the jump object. We've got an enumeration on it for data type and modeling type in the jump object. We set equality. We test when we test for equality, when you try to use equal or not equal, we are testing that you are pointing to the exact same data table, not that the contents matches, but whether it is the same table or not. You can add rows, you can add new columns, you can save the table. You can change the properties, you can change the data table's name, you can read the number of columns and rows. We have a column and we have enumeration types. And the modeling type has these various modeling types. Current returns just like DT current returns the current data table. Open calls jumps open. So you can open whether it's a Python script, and it should open the proper Python aware editor or a JSL script. And it'll open a JSL editor. Table with the name will give you the data table object for the table of that name if it exists. Constants that we have on it. Let me show. So I wanted to show, so for example, and we can do that. So here's a script. So sample scripts, included in the sample scripts is jump to pandas. So this one is a sample script. Wrong screen. So it gives right in our sample scripts, there's a sample scripts Python directory that carries several of these. And this one shows how to create a pandas data frame in two different ways from a jump data table. Easiest is to just let it try and figure things out. It looks at the underlying types and tries to create the table from the type from, and then using column name and from the NumPy array. Or if you comprehensively need to walk through it, you can look at what type the jumps column type is and create a pandas data frame column, and then take the list and generate your columns that way. And then similarly, here's creating a data table from the pandas data frame, just iterating on across the columns by the length of the column. And lastly, for those that still want to pull a copy, I left in place the Python get. So if you do a Python get from JSL of a pandas data frame, it will still use copy to CSV and create a copy in JMP. I wouldn't use that for anything but the smallest tables, and honestly, the rest is, these other ways are easy enough that it makes more sense to do it in memory, but I left that the get for backward compatibility. But like I said, the send sends a JMP data table object, not a pandas data frame.
Do you have a question for Paul?
I do have a question. I first just want to say thank you, Paul, for what you built. I love the integration of Python. And then second, I was curious if JMP has any works of connecting an LLM, a large language model, to the compiler to kind of help with, speed up things if possible.
The large language model, JMP is
Yeah.
looking at some of that, whether, I mean, you can load OpenAI. I've pulled OpenAI into the JMP environment as loading its package. So, if you want to work with playing with some of that stuff, or work developing with that, it is something that you can do from within the Python integration. Actually JMP utilizing it is something where others are looking at.
Yeah, thanks again. I'm really excited about this capability. My question, I wasn't sure if it was answered before because I had to step away for a minute, but is it possible to like pre-bundle Python packages with software installation? Or is the best so that my end user doesn't have to do any of that, or can that just be handled purely through the scripts and doing the installs?
So since we are looking for it in a specific user location, you could pre-bundle. Some one person would have to build in essence, the distribution Python environment. And then it would need to be copied into the user's location that JMP is expecting that site packages folder to be. And that would allow JMP to run. And then, that has been one of the feedback from the user conference, people in higher security environments where they do not want to allow any installations other than a trusted source that here's what we've put for you. So we'll certainly be looking at, so we did support group policy to turn off the Python completely, but I think one of the finer grain things will be there is to support group policy for, say, disabling the pip install, the jpip install functionality from within JMP, as well as maybe some other features to help point out where that directory is, and how to package your own. This is what we want for the user.
Paul, any final words?
There's more to come. We built a framework that dramatically improves on what we had before, and there's more to come.